All right, let's discuss acids and bases. Now, the thing to know about these is that they are everywhere. They're in your food, they're in your house, and they're even inside of you. So, first, let's start with acids. So, an acid is a solution that has an excess of hydrogen ions, so those H plus ions. It comes from the Latin word acidus, that means sharp or sour. Acids will usually donate a hydrogen ion to other substances. So here are some properties of acids. So they taste sour, they conduct electricity, they are corrosive, which means they break down certain substances. For example, many acids can corrode fabric or skin or paper. Some acids react strongly with metals, and they will turn blue litmus paper red. So on the image, you could see there are some examples of acids, and we'll see some on the next slide as well. Um, Commonly, citric acid is found in lemons. If you've ever tasted vinegar, they taste sour because it has an ethanoic acid inside of it. There is ascorbic acid, which is commonly found in vitamin C. So we already mentioned about the acetic or the ethanoic acid in vinegar, citric acid in lemons, limes, and oranges. It is in many sour candies such as Lemonhead and Sour Patch Kids. We talked about ascorbic acid in vitamin C. Sulfuric acid is another example used in the production of fertilizers, steel, paints, and plastics. And car batteries also have acid in them. On the other hand, let's talk about bases. So, a base is a solution that has an excess of hydroxide ions. So, it has those OH negative ions. Another word for a base is alkali, or you might hear the word alkaline. Bases are substances that can accept hydrogen ions. So, before we had acids donating hydrogen ions, bases will accept hydrogen ions. So, what are some of the properties of bases? Well, they feel slippery and taste bitter. They are also corrosive and can conduct electricity. So, if you've ever used alkaline batteries, they do not react with metals and they will turn red litmus paper blue. So, where do we use bases? Well, bases give soaps, ammonia, and many other cleaning products some of their useful properties. We mentioned those hydroxide ions. Well, they can interact strongly with certain substances such as dirt and grease, which makes them really useful for cleaning up. Chalk and oven cleaner are examples of familiar products that contain bases. And in fact, your blood is slightly basic as well. So how do we know if something is an acid or a base or is acidic or basic? Well, we can use the pH scale. So the pH is a measure of how acidic or basic a solution is. The pH scale will range from a value of 0 to 14. Acidic solutions will have pH values below 7. A solution with a pH of exactly 7 is neutral, so that would be your pure water. And basic solutions have pH values above 7. So we can look at our pH scale on the left. So the higher up, we have values from 0 to 7 that are acidic, include things like tomatoes, lemons, hydrochloric acid. we have that water at exactly 7. And then from 7 to 14, we have our basic solution. So those would be our soaps, baking soda, drain cleaner. So continuing on with the pH scale, a change of 1 pH unit represents a tenfold change in the acidity of the solution. For example, if one solution has a pH of 1 and a second solution has a pH of 2, the first solution is not twice as acidic as the second, it is 10 times more acidic. Okay, the pH scale is a logarithmic scale which is based on the power of 10. So, difference of 1 pH has a 10 times difference in acidity. If you go from a pH of 1 to a pH of 3, that's 2 pH units, which is 10 times 10, which would be 100 times more. And last but not least, let's talk about an acid-base reaction. So when you take an acid and you take a base, remember an acid has a pH less than 7, a base has a pH greater than 7, and you mix them together, you get a neutralization reaction. They neutralize each other. So an acid-base mixture is not as acidic or basic as the individual starting solutions. So we can see here when we took our base with a pH of 12 and our acid with a pH of 2, we mixed them together to get a new solution that is a pH of 8. In fact, when you do a neutralization reaction, you will get a salt plus water as your products every single time.